Good morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, we are going to discuss about a very important topic in probability and statistics, that is probability density function. What is meant by probability density function? See, already in probability statistics, we have discussed about two main variables, random variables. They are discrete random variables and continuous random variables. In discrete random variables, what do we see there? In discrete random variable, it gives a specific numerical value, whereas in continuous random variable, it gives is a value which lies in a range, which lies in an interval. That is the main difference between a discrete random variable and continuous random variable. Previously we have discussed the probability distribution for discrete random variable. It is known as probability mass function. In the same way, we define probability distribution for continuous random variable. It is known as probability density function. So, the main difference between probability mass function and probability density function is probability mass function is a probability distribution defined for discrete random variable, whereas the probability distribution which is defined for continuous random variable is known as probability density function. So the probability density function, it is a type of probability function. That probability function, it is defined for continuous random variable. Now let us see its functions, its structure. Here, the probability density function is a function that provides the likelihood that the value of a random variable will fall between a certain range of values. Why? Because it is defined for continuous random variable. So we use the probability density function in the case of continuous random variables. For discrete random variables, we use the probability mass function, which is analogous to the probability density function. The graph of probability density function is in the form of a bell-shaped curve. So, the area that lies between any two specified values gives probability of the outcome of the designated observation. So, under probability density function, we will find area lying between certain intervals, and for various values of continuous random variable, what will be the occupied area? All these things we will discuss now. We solve the integral of this function to determine the probabilities associated with a continuous random variable. So now we are going to do a detailed analysis of the probability density function and take a look at the various aspects related to it. Let us see what is probability density function, PDF. probability density function and cumulative distribution function are used to define the distribution of continuous random variables. Now let us see, if we differentiate the cumulative distribution function of a continuous random variable, it results in the probability density function. Why? First of all, we know the cumulative distribution function. Cumulative distribution function, it lies between some low interval and upper interval. In between, it ascends or descends. So, in this, if this continuous random variable, it results in the probability density function. Conversely, on integrating the probability density function, we get the cumulative distribution function in a similar way. Now, mathematically, let us define probability density function. Probability density function defines the density of the probability that a continuous random variable will lie within a particular range of values. Why? Continuous random variable always shows it lie for a particular range. Yeah, it lies in an interval. That's why this probability density function also, it shows its density for a particular range of values. To determine this probability, we integrate the probability density function between two specified points, lower limit to upper limit. Why? Because the probability, the continuous random variable, it is lying in some range of values. So that function moves from one point to other point. That's why the probability density function also gives the density of that function from that point to other point. That's why we integrate between two specified points. Now let us see some nice example for probability density function. Say we have a continuous random variable whose probability density function is given by f of x is equal to some x plus 2. It is the function we took randomly when 0 less than x less than or equal to 2. Now what we have to do? We want to find probability of 0.5 less than x less than 1. Particularly it gives some area. Then we integrate x plus 2 within the limits 0.5 and 1. Thus, if we integrate this within the limits 0.5 and 1, its value is 1.375. So, thus, the probability that the continuous random variable lies between 0.5 and 1 is 1.375. Let us integrate between the limits 0.5 and 1. Integral of x plus 2 dx between the limits 0.5 and 1. Its value is 1.375. Now, let us try to find the formula for probability density function. The probability density function of a continuous random variable is analogous to the probability mass function of a discrete random variable. Discrete random variables can be evaluated at a particular point, while continuous random variable have to be evaluated between a certain interval. This is because the probability that a continuous random variable will take an exact value is 0. Given below are the various probability density function formulae. Probability density function of continuous random variable we can discuss like this. Suppose we have a continuous random variable x. Let f of x be the cumulative distribution function of x. Then the formula for the probability density function f of x is given as f of x is equal to derivative of capital F of x by d. It is equal to f dash capital F dash x. Here what is the difference between small f of x and capital F of x? Small f of x is the probability density function of capital F of x. So if you take the derivative of capital F of x, it gives the value of our probability function small f of x. It is also known as capital F dash x. It is our denotation. So, if we want to find the probability that x lies between lower limit a and upper limit b, then using the probability density function, this can be given as P of a less than x less than or equal to b. Here we are taking the probability between a and b, and strictly it doesn't take a, but it can go up to b and it can take b. That is a less than x less than or equal to b. So definitely this probability gives us some area. So probability of a less than x less than or equal to b, definitely it gives the difference of values obtained at capital F of b and capital F of a. So it is nothing but capital F of b minus capital F of a. Here don't get confusion between small f of x and capital F of x. Here small f of x stands for probability density function. Capital F of x stands for the given functional value at a and b. That is the difference between small f of x and capital F of x. So here how it is defined? Probability of a less than x less than or equal to b is equal to value obtained at b, so capital F of b, minus value obtained at a, capital F of a. So totally it gives us the result of integral a to b f of x dx. So this entire place gives us some area. Here capital F of B and capital F of A represent the cumulative distribution function at B and A respectively. Now let us see the probability density function of normal distribution. Previously we discussed so many times, when do we say the given distribution is a normal distribution? If the given distribution, probability distribution has mean value 0, means mu is equal to 0, and standard deviation 1. So when mu is equal to 0 and standard deviation, when mu is equal to 0 and standard deviation is equal to 1, then we say it is a normal distribution. It is a normal distribution. So now we are defining PDF, probability density function, for normal distribution. Normal distribution is the most widely used type of continuous probability distribution. So in normal distribution, if we find this probability, it gives some area lying between the x-axis and the curve f of x. That curve shows a bell-shaped curve. So under that curve, we will get some area. That area is represented by P of A less than X less than or equal to B. The notation for normal distribution is given as X maps to normal distribution for mu and sigma square, where sigma square stands for variance, sigma stands for standard deviation. The probability density function of a normal distribution is given by f of x is equal to 1 by sigma into square root of 2 pi into e to the power minus 1 by 2 into x minus mu by sigma whole square. Here in further, the value here what we are using, x minus mu by sigma, it specifically gives some value z. It is called statistic. Z, small z value, it is known as statistic. That value is small z is equal to x minus mu by sigma. This value is called statistic, and this is useful. This value we use while we calculating and while we doing sums in a test of hypothesis. Testing of hypothesis, we use this value z is equal to x minus mu by sigma, where x is a random variable, mu is a mean or expected value, and sigma standard deviation. Using these three, we find z value, that is called statistic. If this statistic is less than 1.96, we accept that hypothesis. If it is greater than 1.96, we reject that hypothesis. So while calculating, while we test the test of hypothesis, we use this word x minus mu by sigma. So in this formula, the probability density function of a normal distribution is given by f of x is equal to 1 by sigma into square root of 2 pi into e to the power minus 1 by 2 into x minus mu by sigma whole square. So this is the probability density function for a normal distribution. Here mu is the mean and sigma is the standard deviation, where sigma square is the variance. So this normal distribution curve comes as a bell-shaped curve like this. Now this bell-shaped curve, let us analyze now. The probability, this is nothing but the probability density function graph. It gives us a graph. If x is a continuous random variable, then the probability distribution of this variable is given by the probability density function. So here f of x is defining by this curve like this. So under this curve, some area is defined here. Whatever I am showing here, this area represents P of a less than or equal to x less than or equal to b. It is lying between x is equal to a, x is equal to b, x-axis and f of x, this curve. So the area surrounded by this curve is P of a less than or equal to x less than or equal to b. The graph given below depicts the probability that x will lie between 2 points A and B. Graph of probability density function, so we can show like this. Now let us define mean or expected value, both are same. Mean of probability density function. In the case of probability density function, the mean is the expected value of the average value of the random variable. If f of x is the probability density function of the random variable x, then mean is given by the following formula. Expected value or mean value E of x is equal to mu is equal to integral minus infinity to infinity x into f of x dx. This gives the formula to find mean for a probability density function. We can estimate, we can find the mean of continuous random variable x as E of x is equal to mu is equal to integral minus infinity to infinity x into f of x dx. Using this formula, we can find mean or expected value of given data. Now let us define median of probability density function. In the name itself, mean means what? The central value, the central tendency. So how do we find the median of probability density function? See, median means it gives a central value. So half of the value. The median is the value that splits the probability density function curve into two equal halves. Suppose x is equal to some m, say, is the value of the median. The area under the curve from minus infinity to plus infinity to that curve goes from minus infinity to m will be equal to the area under the curve from m to plus infinity. So thus the median of the probability density function we can see like this. Now let us see the graph. In that graph the area is divided into two equal parts. Here M is the central part, small m is the central part. Now the area surrounded from minus infinity, here it is minus infinity you can say, here plus infinity you can take. So the area lying between minus infinity to m, minus infinity to m, x into f of x dx. So if you calculate, or the value calculated from minus infinity to m f of x dx, integral from minus infinity to m f of x dx is nothing but it is numerically equal to integral m to infinity f of x dx. Both values show half. So the entire area should be equal to 1. So the area from minus infinity to m f of x dx is equal to the area from integral m to infinity f of x dx. This is half. So here what is median? The dotted line which shows here is median graphically. It exactly gives the central value, it exactly divides into exactly half. So graphically we can understand the median concept like this. Now let us see variance of probability density function. Variance means sigma square, standard deviation whole square. The expected value of the squared deviation from the mean is the variance of random variable. If we express this definition mathematically, we can get variance of x is equal to E of x minus mu whole square. Elaborately, this can be written as variance of x is equal to, it is mathematically sigma square is equal to integral x minus mu whole square into f of x dx. So variance of x is equal to sigma square is equal to integral x minus mu whole square into f of x dx. It is called variance. Now let us see properties of probability density function. The properties of the probability density function help to solve questions faster and easier. If f of x is the probability distribution of a continuous random variable x, then some of the useful properties are listed below here. F of x is always positive. F of x is greater than or equal to 0. This implies that the probability density function for all real numbers can be either equal to or greater than 0. Second one, but it can never be negative or less than 0. Third one, Thus, the total area under the probability density curve, suppose as we seen in the area under the bell-shaped curve, will be equal to 1. Now let us see some important noteworthy points of this probability density function. Probability density function determines the probability that a continuous random variable will fall between a range of specified values. On differentiating the cumulative distribution function, we obtain the probability density function. We saw there f of small f of x is equal to derivative of capital F of x, it is f dash x, we saw previously. That is this one. On differentiating the cumulative distribution function, that capital F of x is nothing but cumulative distribution function. We obtain the probability density function. The mean of the probability density function we can find same like that, as the median divides the probability density function curve into two equal halves. Its value will be, each value will be equal to 1 by 2, 1 by 2. So probability density function properties, once again we can discuss. Let x be the continuous random variable with the density function f of x, and the probability density function should satisfy the following conditions. For a continuous random variable takes some value between certain limits, say a and b. The PDF is calculated by finding the area under its curve and the x-axis within the lower limit a and upper limit b. Thus, the probability density function is given by some probability PDF is given by integral minus infinity to infinity f of x dx. So let us see some applications of probability density function. PDF, probability density function, that is, the probability density function has many applications in different fields of study, such as statistics, science, and engineering. Some of the important applications of the probability density function we can see like this. In statistics, it is used to calculate the probabilities associated with the random variables. The probability density function is used in modeling the annual data of atmospheric nitrogen oxide temporal concentration. It is used to model the diesel engine combustion. The major difference between the probability density function PDF and the probability mass function PMF is that PDF is used to describe the continuous probability distribution, whereas PMF is used to describe the discrete probability distribution. Now let us see how to find probability density function in statistics. Let us see some main steps. Among them, first one is summarizing the density with a histogram. Like that, using some histogram, let us try to summarize the density. For that, first convert the data. Whatever data is given, you just convert into discrete form, numerical form, by plotting it as a histogram as shown there. A histogram is a graph with categorical values on the x-axis and bins of different heights, giving you a count of the values in that category. The heights giving you a count of the values in that category. The number of bins is crucial as it determines how many bars, these are bars, how many bars the histogram will have and their width. This will tell you how it will plot your density. So, one more step, performing parametric density estimation. What is parametric density estimation? A PDF, parametric density estimation, PDE, can take on a shape similar to many standard functions. The shape of the histogram will help you determine which type of function it is. You can calculate the parameters associated with the function to get our density. To check if our histogram is an excellent fit for the function, like that we can see. So, for that, plot the density function and compare histogram shape. Compare samples of the function with actual samples. Use a statistical test. So many statistical tests are there for that given particular data. Which type of test is suitable? You judge it, take it and test it. Now let us see performing non-parametric density estimation. In cases where the shape of the histogram doesn't match a common probability density function or cannot be made to fit one, you calculate the density using all the samples in the data and applying certain algorithms. One such algorithm is the kernel density estimation. This kernel density estimation is a type of algorithm. It uses a mathematical function to calculate and smooth probabilities so that their sum is always 1. To do this, we need the following parameters. Smoothing parameter, bandwidth. It controls the number of samples used to estimate the probability of a new point. Basis function is there. It helps to control the distribution of samples. So let us see recapitulation of this topic, probability density function. So this probability density function, it is evaluated in a particular range. The probability density function of continuous random variable can be defined mathematically as f of x is equal to derivative of continuous random function f of x is equal to f dash x. So when do we say the given distribution is a normal distribution? When mean is equal to 0 and standard deviation is equal to 1, then we say it is a normal distribution. So for a normal distribution, the probability which is defined between the values a and b gives us some area, that is p of a less than x less than or equal to b is equal to f of b minus f of a. It is also known as integral a to b f of x dx. Though the probability density function can be evaluated using the formula f of x is equal to 1 by sigma into square root of 2 pi into e to the power minus half into x minus mu by sigma whole square. Here x minus mu by sigma gives a specific value. It is called statistic, denoted by the letter z. Its value we use while we calculating the test of hypothesis, whether the test has to accept or reject. We judge using this parameter statistic z. Z is equal to x minus, by calculate this value, z is equal to x minus mu by sigma. We judge whether the given matter, given data has to be accepted or denied. So the probability density function graph we can see with the help of this bell-shaped curve. So the expectation mean of probability density function can be calculated using the formula E of x is equal to mu is equal to integral minus infinity to infinity x into f of x dx. So the median of probability density function exactly comes at mu is equal to 1 by 2. If we see this bell-shaped curve, the m value at 1 by 2, this median is taking same area from minus infinity to m f of x dx, and is numerically it is equal to integral m to infinity f of x dx. Clearly we can analyze and see this fact using this graph. So let us see, calculate variance. Variance of x is equal to sigma square is equal to integral x minus mu whole square into f of x dx. Now let us analyze some properties. F of x greater than or equal to 0. It never be negative or less than 0. Thus the total area under the probability density curve will be equal to 1. some important noteworthy points let us discuss. Probability density function determines the probability that a continuous random variable will fall between a range of specified values. On differentiating the cumulative distribution function, we obtain the probability density function. The mean of the probability density function can be defined. The median divides the probability density function curve into two equal halves. This value will be equal to 1 by 2. So let us see some applications of probability density function. The probability density function has many applications in different fields of study such as statistics, science and engineering. So the major difference between the probability density function PDF and the probability mass function PMF is that PDF is used to describe the continuous probability distribution, whereas PMF is used to describe the discrete probability distribution. Now we can find the probability distribution function in statistics by calculating with the help of histograms, by performing parametric density estimations, by performing non-parametric density estimations using the parameters bandwidth and basis function. So probability density function, it gives the density of probability function with respect to the continuous random variable. This is probability density function. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.